Welcome guys, this is Gagan from livelearnings.com and this is the 8th video tutorial of PIC16F886. In this video tutorial, we will learn about the need of transistor as a switch and how we can use a transistor as a switch. Then we will move to the working of relay and we will control a relay from a microcontroller pin. You can see the symbol of NPN transistor on left side and the PNP type transistor symbol on right side. In this video tutorial, I will show you how you can use NPN transistor to control the loads. For this purpose, I will use this transistor BC547. Let's move to the Proteus simulation side. To add the transistor in device list, click on P and type BC547 and you can select this package for NPN transistor. Double click on it to add it into the device list. Next we need a resistance, type RES and select this resistance and click OK. Now place the transistor on the screen. Place the resistance near to this terminal. This terminal is the base of transistor and this resistance is to limit the current to base. So when we are using a NPN transistor, we will always connect the emitter of the transistor to ground signal. So place a ground near to the emitter terminal of the transistor. We will connect the load on collector terminal. Suppose this red LED is our load. Connect the cathode of LED to collector. Connect a current limiting resistance to LED of value 330 ohm and connect power to the other end of resistance. Now search for a button, type button and select this SPST push button. Connect one end of the button to the one end of resistance which is connected to the base of the transistor. Now this BC547 transistor is a NPN transistor. Because base is positive, we need a positive signal to turn on the transistor. Place the power source and connect it to the other end of the switch. Now run the simulation. Now when the button is not pressed, what is the state of LED? It is off. Now press the button, LED is turned on. Release the button, again the LED is turned off. So it is clear from this concept that when we provide a high signal on the base of a NPN transistor, it will provide a path to current from its collector to its emitter, and if you connect your load in this configuration, then the load will be activated. Now if the load is only one or two LEDs, they will consume very little current and you can operate the LEDs directly from the microcontroller pin. Now suppose you want to switch heavier load which consume more current and require more voltage to turn on, then you can't connect that load directly to the microcontroller pin, because if we consider PIC16F886 microcontroller, the microcontroller pin can only provide 20 or 25 milliamps of current at 5 volts. So we can't directly drive heavy loads from the microcontroller pin. So for that purpose, we are using a transistor as a switch to drive heavy loads, because this transistor will get a very small current from the microcontroller pin and it will turn on a heavy load. Let's consider the other switching device, which is a relay. So this is a relay rated for 12 volt DC and you can switch 250 volt AC or 30 volt DC maximum at 10 ampere. So this type of device you can use to turn on AC as well as DC loads. Let's discuss the working of this relay. To add the relay in device list, type relay and select this animated relay model. Double click on it to add it into device list. Now this is the package of relay in Proteus ISIS. You can see on left hand side, this is the coil of the relay, and on the left hand side, this is the mechanical part of the relay. So in a relay, there are two main parts. One is the energizing coil, which is on the left hand side, and second one is the contacts of the relay. This 12 volt is the operating voltage of the relay coil. So we need minimum 12 volts to energize the relay coil. So let's connect a 12 volt supply on this terminal of the relay. For this, you can go to this generator mode, click on DC source and place the source on this side. Double click on the source, make sure it is selected for DC and type the required voltage. Place a button near to the other end of the relay coil. Place a ground terminal and connect it to the other end of the switch. Now run the simulation. You can see what is the initial state of this relay contact. It is connected to this side. Now press this button. You can see this contact has changed its position. Release the button and it will again come back to its initial position. This contact of the relay is called a common contact. This contact of the relay is NC. This contact of the relay is NO. So NC is a contact which is connected to the common when relay is not energized. When you are pressing this button, it will complete a circuit and a current will flow through the relay coil, and this relay coil is an electromagnet which will attract this contact towards its side, and this contact will shift from NC to NO, and whatever the supply you are providing to this common terminal, you will get the output from this NO terminal. Again, if you release the button, this relay coil will de-energizes and this contact will move to NC contact by a spring action. So we can connect AC supply or DC supply on this common terminal. Let's connect a DC source of 12 volt on common terminal. Now I make the circuit in this arrangement. I connect 12 volt supply source on the common, and one LED is connected to NC terminal and second LED is connected to NO terminal with 330 ohm resistance, and these two terminals are connected to ground. Run the simulation. Now you can see by default this LED is turned on. If the switch is not pressed, this LED is turned on because this terminal is connected to common and this is the NC terminal. If you press the button, this LED will get the supply and this will not get the supply. Let's see how we can control this relay with the help of a transistor, and we will replace this button with a transistor. So this is the arrangement of a NPN transistor as a switch. Load is connected on the collector terminal of the transistor. Remove this load and connect the collector of this transistor to the second end of the relay coil. Run the simulation. You can see the contact is on this side. Press the button and you can see this contact is shifted to this side. If we try to connect this relay directly to the microcontroller's pin, definitely the microcontroller pin will get damaged. So never connect heavy loads directly to the microcontroller's pins. Now for our simulation, I am connecting RC0 pin to the base of this transistor through a 10K resistance. We have to provide a positive signal to turn on the transistor. First, I will give a name to that transistor pin and I will define a name for tri-state resistor bit also. So let's first make the pin as an output. Then I will create an infinite loop with while 1. Now to turn on the transistor, type load 1 is equal to 1. After that, I want to provide a delay of 1 second. So delay underscore millisecond 1000. Load 1 is equal to 0 means turn off the transistor. Then again a delay of 1 second. So you can give a command to any line by using these two forward slashes and write whatever you want to write for that line. You can see when this transistor is activating the relay, when there is a high signal on the pin, and this red color means high signal and the blue color means a low signal. So when there is a high signal on the base of this transistor, this will provide a path of supply from this relay coil, and this relay coil will attract this contact toward this side, and we will get a supply output from this NO terminal, whatever you are connecting on this common terminal. So when the relay is off, this contact will automatically shift to this side because of the spring action, and you will get the supply output from this common to this connection. So guys, this is how we can control a relay with a transistor, and by the help of relay you can control AC or DC loads. So try to write your own logic and don't forget to subscribe my channel. Thanks for watching.